Hello everyone, welcome to the third part of this series. Now to recap this circuit that you have drawn already and simulated, here's what we have done already. We have a voltage source, a multimeter, a resistor, and an earth point. We have simulated this and we also have gotten some pretty nice graphs for the instantaneous current, instantaneous voltage, power, reactive power, and active power as well, and the three-phase line-to-line voltage from the source as well. Those are all graphed, and we can see that those are sinusoidal waves. So let me explain to you guys how this thing work basically. Um, let's take a screenshot. Okay, so what happens is that this multimeter is taking the signal from multimeter to this signal point, which is the I inst, and we need these signal points to grab that data from there. This I inst data point or signal point takes that data into this. You can call this a scope, and this scope is basically outputting this graph. So this is how this is going to work. This is how you will always work with signals when you want to graph something or when you want to draw something on the grapher or on the plotter. So now that this is done, we want to experiment with something new and add new components into this circuit and see how we can use Pscad for our purposes. So next, I am going into something called breakers and introduce a switch, a time-based switch that will turn on and off when the time in the simulation reaches to a certain point. We will set that in the settings. And to do that, we can go to the main library, which is here, and then go to the more on breakers and faults, because this is where the breakers are. Now we have different types of breakers here. The one that we need is this one because this is a three-phase breaker, and to identify if it's a three-phase or a single phase, it's written here, mentioned here as well, but you can also identify this with this bold line, this big bold black line, and you can see for the single phase it's not bold. So we need this breaker. We can copy this one and put it here. So there you go. The breaker is there. I just want to make sure that I don't have a double breakers because that can cause problems. Looks like we are good to go. So this is the breaker. Now reverse the position by pressing R because we want to match with the power flow of this breaker. So this breaker should be in between the resistor and the multimeter. Now this looks like this is connected, but it's not actually connected because we need to make sure that all the components are connected properly. I'll delete that and put this here and then check again if yeah, everything is good there. Now put this back here. Yeah, everything is connected. I can double click on it and see its configuration and properties, and also the name of this breaker is three-phase breaker. I can go into configuration and check all the settings, but this is not going to work without other certain elements that are absolutely necessary for this breaker to work. So I can go this window in a moment. First, let's get all those essential components that are required for this breaker to work. So here we go. These two are the main things that are needed for the breaker to work. First is the signal, because this breaker is just a component and we need to control this as well. In order to control that, we need this other block called the time breaker logic closed at T0 or T0 or a specified time that you specify for the breaker. So this is the controller. It sends the signal to this signal receiver or the BRK, and this BRK is basically sending the signal to this breaker, which is controlling the breaker on the specified time, which means this is outputting either a 1 or a 0, and that is turning on or off the breaker. So if I double click on this, it has some parameters, and you can see this is timed breaker logic. So we need to define the logic here. For this one, number of breaker operations, we are going to select 1 because we want only the breaker to operate once in the process, not twice. Next is the initial state is closed. So let's keep that closed, and the first time of first breaker operation, let's keep that at 10 seconds. So after 10 seconds, the state of the breaker will change, and we can see all of that in the graphs when we are in the circuit. Now, the name of the signal and the name of the breaker should be same, because this is basically sending the signal, the 1 and the 0, the on and off, to this breaker through this signal. Now we have selected or set the duration of the run for this simulation at 20 seconds, and at 10 seconds we are seeing if something happens with the breaker, because that is when the state of the breaker will change, and we can see that in the outputs of these graphs. I have reset the scales of the graphs because we want to see what is happening. So I will go to properties, uncheck this one because R, and all I'm doing is pressing on R to reset the scales of these graphs. Finally, this one, let's also uncheck this one and press on R. All done. Now let's simulate the circuit and see what we get in these graphs. I'll zoom out a bit so that we can see all the graphs. Oh, we cannot see properly. Anyways, let's just run this project. Now you can see for the 10 seconds, we are getting some output, because that is when the breaker is open or the current is passing through the breaker. And after this 10 seconds, the current drops to 0, because that is when the breaker is operated and the breaker is opened or it's turned off. So the timed logic is sending a 0 signal at t is equal to 10. That is when the breaker is closed. And we can also see all of these other data. You can how the breaker is operated in Pscad. Next, after this, I will also include a button that will be used to operate the breaker. So we can have some manual buttons as well. This was an automatic, a time-based breaker. We can have a button or a switch that will be used to control this breaker. So stay tuned for that one as well.